Hello everyone, this is the libhal meeting. It is October 5th, 2022. Let's get started. So, should be a pretty quick meeting this time. Not too much to show when it comes to the iteration highlights. This is pretty much the only one. So the first thing we're going to go over is the LPC CAN driver. That's nearly done. I'm nearly complete with that. I should be merging that in probably within this week. Got the timing down, and one of the things that I've also changed here is that the CAN bus interface has actually had one big change. I'm actually going to show you here. Let's see if I go to commit. Yeah. Yes, so we now have the bit quanta timing added into the settings for the CAN bus driver. So not only do you put in your actual baud rate that you desire, but also your segment, you don't choose your segment, your sync segment, but your propagation delay, your phase 1, your phase 2, synchronization, jump width, and stuff like that. And it also comes with some helper functions to define the bit width, as well as also is it valid, checking to see if this whole thing's valid, and it returns back the prescaler value given a input frequency. And we'll tell you for the most part if what you've given it is actually even possible. But it will be kind of soft in that requirement, because if you give it something like 2.75, technically that shouldn't be possible. It should be an integer divider. But we leave that to the implementation to handle. We may change that in the future. So yeah, so that's pretty much that. The CAN bus library for LPC should be done pretty soon. And that brings us to our next item here, which would be the potential early adoption for robotics, or biorobotics. The robotics team is very interested in moving over to libhal sooner than later. Originally, we had a plan for end of winter time, beginning like January 1st, around that time. But I think they're wanting to move over to it sooner than later, and I think it's actually a good choice. As they're getting new members and people who are working with them, it's probably better to move to libhal sooner and get everyone adopting that than it is later. Next up, we have Web Tools. So Web Tools is a new project in the whole libhal scheme. This really just came down to the fact that there were so many different tools online that I really did like and appreciate and enjoy, but they had one severe problem, is that you couldn't really share them. So the whole point of this is to basically build projects to calculate things for engineers, like needed torque for a robot, or how fast does your SPI clock need to be to get a certain refresh rate. But the main thing we're looking for is shareability. I want you to be able to take a link, or after you make your calculation, be able to copy the link and then post it somewhere else. What I found in the past is that certain types of tools online, you can put the information in there and they'll calculate everything just hunky-dory. But the problem is you can't share it. So you either have to make a screenshot, make a long screenshot if you know how to do that, multiple screenshots, or to send out what the text of the inputs are and then send that to someone else, and hopefully you didn't make a typo, and hopefully when they put the stuff in, they don't make a typo. This should help get rid of a lot of that stuff that we have to do quite often. And I'm hoping to have more than just the things I've said in the top. Any sort of tool would be great for this. And this is really just to enable and help out libhal. Completely free, open source, available for anyone. Hopefully super portable, so you can also use it offline. The whole point of this is really be able to be used offline so that no one feels afraid that we're mining their data, none of that. And yeah, the whole point is prevent typos, prevent storage bloat by having to share images around, and obviously to speed up calculation and communication. I want to be able to tell someone, yeah, this robot's going to require a motor with for each leg, 5 Newton meters for it to be able to work. And I shouldn't have to, send them, scribbles on a piece of paper. I shouldn't have to send them screenshots. I should be able to send them a single link and they get the results they're looking for. And that's pretty much the Web Tools. Next up, we have struct return for every interface API. So for all the interfaces, we're actually going to move away from what we had before, which is result float or just individual items, to returning back a structure. And you're wondering, well, why would we do that? Well, the whole point of this is to make every single one of the APIs extendable in the future. It is a bit uglier, I understand that. But if the return value has to change in the future, such as adding an additional field, a structure with default initialized values can make this happen. For example, if we look below here, we have this read structure that takes back a %. Now it's not defined, so if you have your compiler settings set properly, which you should have these warnings set up, it should tell you if you try to return this read structure with % undefined, it'll yell at you saying, hey, you do not undefine this value. You're trying to return an uninitialized value. Whereas if you have this thing here, you can have percent, and you have something that's default initialized. Optional will actually default initialize whatever it is, so you don't have to even worry about initializing it yourself. But if you could, you could put some curly braces down here to say, I want to default initialize this. But the idea here is that as time goes on, we can add more and more fields to our return types. So if we ever find out there's some users like, oh, because of this actually is completely useless. This interface is completely useless to us. We can't support it. But, a lot of clients, a lot of people who are looking at our software, a lot of users realize that, yeah, without this other bit of information, the whole thing is pretty much useless or suboptimal. So then we make a decision. We say, all right, let's update the return type. All the original code need not change whatsoever for this to change for them to take it on. There'll just be code that just doesn't support the latest API, and they would have already been used in cases where they were optimal. And if they get updated later on, they can have the optimal return values. And that's pretty much the idea. So if you were to ever get a return value back from ADC, you'd get read type, ADC read type, and you'd have to use whatever that read type is, dot, or whatever the variable name is, dot percentage to get the actual percentage out. It's going to be a little bit more noisy, a little more verbose in the code, but because of this, we basically get extensible return values without breaking APIs in the future. And you can think a bit about it similar to how if we required some type of input for read, doesn't make sense, but let's say we did, we can just put the new parameter in there and default initialize it, and then pass that default initialized value into the virtual function. And that's how we can basically add more APIs over time without breaking our users. It does get a little weird because the virtual APIs will need to have these too, and that could cause some issues. That could cause some issues. But we'll have to look into how we can fix that. One other idea is just to use a structure here, and then always pass the structure through and have optional values inside the inputs. I'm going to investigate that, see if that's reasonable, but I'm hoping we don't need to. But if we do need to, then we might go that route as well. So a structure return and a structure as an input, just so that we can make sure that the APIs can evolve over time without much issue. This is very similar to how Linux actually does it. And that's pretty much it for the meeting today. Not super duper too much, but I have some other things to go over afterwards. So let me stop the recording.